Which of the following represents the most stable conformation of trans 4-tert-butyl cyclohexanol? And so whenever you're dealing with a cyclohexane ring, the most stable conformation is always going to be some sort of chair conformation. And then from there, these are all chair cyclohexanes. We want to make sure that we have actually represented the trans 4-tert-butyl cyclohexanol. So this trans means that one substituent is pointed up. So one group is going to be pointing up, and one group is going to be pointing down. So what you need to be able to do, first of all, is be really comfortable with your cyclohexane chair conformations. So I'm going to draw just a plain chair up here. So there is the cyclohexane chair. And what we want to be really comfortable with is the location of the axial and the equatorial hydrogens. So on every single carbon atom of this ring, you have one bond that's pointed straight up, and that is your axial bond, or it might be pointed straight down. And so we can locate these. Whenever the vertice of the ring is pointed up, your axial bond is going to be angled up. Here it's pointed down, so the axial bond is down. So I can go ahead and fill these in around the ring. Notice they alternate up, down, just the way the vertices alternate on that ring. So knowing where your axial bonds are will give you a good indication of where your equatorial bonds are. And typically we want to have our larger substituents on equatorial bonds. And that's what's going to guide us in answering this problem. So wherever your axial bond is pointed up, your equatorial bond, so equatorial for equator, it's pointing to the side, but it's going to be angled slightly in one direction or the other. So if the axial bond is angled up, your equatorial will be angled down. Let me switch colors for equatorial. So there we go. Axial down, so equatorial is up. Axial is up, so the equatorial is down. This axial is down, so the equatorial is up. Axial up, so equatorial down, and finally axial down, equatorial up. Okay, so now we've got this whole framework. And so we want to draw 4-tert-butyl cyclohexanol. So I would start by drawing this ring, and here's what I want to recognize. I want my largest substituent equatorial. That tert-butyl group with all that branching, I really want that to be on an equatorial bond. So I'm going to pick an equatorial bond. I'm just going to pick one here, and I'm going to draw that tert-butyl group equatorial. And the first thing I'm going to notice is that this is a down bond. So we are looking at the bond coming from the carbon to the first carbon to see what angle that's at. Because this is trans, that means I need to count 4 carbon atoms away. 1, 2, 3, 4. And when I put in my alcohol, I need to make sure that it's pointing up. And so what I've done, I've matched 1, 2, 3, 4, and I see that the up bond at that carbon atom is also equatorial. So that's where my alcohol is going to be. So the strategy is to draw the chair, take your larger substituent, place that equatorial, and then follow what you're given to tell you where the next group is going to be. So this is trans because this one is pointing down and this is pointing up.